Welcome to the ITC class Information Theory and Coding. This is ALIAS George live from NIT Calicut, and today we will be dealing with the coding theory part, and I will be teaching the BCH codes and the Reed-Solomon code. So that is the agenda for the today's class, and after that I will be discussing some problems from this coding theory. Is it okay? Yes or no? Yeah. So we have taught the linear block codes LBC block. Then after I moved to LBC cyclic codes. After that I taught you what convolution block codes, CBC codes. That's what that till we reach now. Next we are learning the BCH code. Let me ask you why we are learning the BCH code and Reed-Solomon code. The Reed-Solomon code are known as RS code. So why BCH and RS? Or what are the limitations of LBC and CBC? Yeah, from LBC and CBC, we know that the maximum number of errors detected is what? D minimum minus 1, and it can be corrected how much? D minimum minus 1 by 2. And we also know that in LBC and CBC, the input number of bits is fixed, right? The LBC is what? N comma K. Suppose it can be 4 comma 3. Can it be 1 comma 2? Then no use of coding. Actually, we are adding the redundancy to remove the errors, right? So this combination not possible. N should be greater than the K, right? Why no response? What happened? Yeah, that is LBC representation. And why CBC? N comma K comma M. This was the representation, right? So actually here the input number of bits is fixed. We can only feed to the system only 3 bits at a time, and we will getting 4 bits. That's how we learned LBC and CBC, right? Now here the main idea is that here the system is dynamic. System is dynamic means the K is not constant. K can be varied. So it can be 2, it can be 3, it can be any value. That is what BCH, and BCH we can fix the number of errors. In LBC the problem is what? Maximum number of errors detected or can be corrected is what? D minimum minus 1 by 2. But here we can initially take that this system will correct 3 or 4 bit errors. So the errors or the bit error we can control in BCH and RS code. So I am introducing you a new coding concept, that is what? BCH code or Bose Chaudhary Honken Khum codes. I don't know the pronunciation is correct. It's the credits goes to the developers of this code, and this code is nothing but it is also called multiple error correcting code. So we can fix the number of errors here that can be corrected using this code. So what are the properties will be there? So properties, the first of all, a number of errors can be corrected will be there, right? That is equal to T, right? Yes or no? Here we can fix how much number of bits can be corrected initially. So I took it as 3, and this is defined over GF2 extension. This is binary codes, so only 0 and 1 and its extension. So it is defined over this is binary system. So it is defined over GF2 or its extension, or in short we can write it as what? Galois field extension 2 to the power m. Is it clear? Is it everyone clear? Yes or no? Yeah. Then number of outputs or the bit output, we usually denote it as what? N, or the block length, that is 2 to the power m minus 1. In this case, it is GF, the extension of 2 to the power m. So these are predefined properties. Here the block length will be n is equal to 2 to the power m minus 1, and the number of redundancy bits or the parity bits n minus k will be greater than or equal to m times t. What is t? Number of? Yeah. And what is m? Extension. So for GF 2 to the power 4, what is m? 4. And what is n? 15. So 15 minus k can be greater or equal to 4 into, if 3 correcting codes means how much? Into 3. So k can be maximum less than can be 15 minus 12. So k can be less than or equal to 3. So its representation is what? N comma k representation. So this, you remember, this is same LBC cyclic codes. So all the properties of LBC cyclic codes can be applied here. Only the difference is what? K is less than or equal to 3. It is not fixed. So what is the representation? Take out the maximum value. So n is what? 15 comma 3. It is represented by like this. So 15 comma 3 BCH code. Is it clear? Yes or no? Yeah. Then the D minimum is equal to 2t minus 1. This equation we know, right? Errors can be corrected is what? D minimum minus 1 divided by 2. D minimum minus 1 divided by 2. So this equation is very known. I have written in the other form. Number of errors can be dictated is what? D minimum minus 1 can be corrected is what? D minimum minus 1 divided by 2. You know this one, right? So I have written in the other form. So it is greater than or equal to. Is it clear? These are the fundamental properties. And one more, the main property is what? It is a cyclic LBC code. We have learned what is cyclic LBC code, and we have generated a code polynomial there. From code polynomial, we have concluded to a matrix, how to convert code polynomial to matrix. All that properties can be applied here. So what is our next aim? To find out code polynomial. That's our aim, right? If the representation, if n is given, it is asked that BCH is defined over 2 Galois field extension 2 to the power 4. So the first aim is find out the block length n. What is n? I need everyone's response. What is n? 2 to the power 4 minus 1, that is 15. And what is k? If 3-bit error is there, what? It is less than or equal to 3. So it can correct maximum 3 errors using the redundancy n minus k. What is n minus k here? N minus k is what? Greater than or equal to 4 into 3. So how much redundancy bits? Extra bits. How much? N minus k is how much? 4 into 3. So how much extra bits? 3 extra bits. How much message bits are there? How much message bits? 3. So you can see that if I am drawing a diagram like this, if this is n is fixed and the k is variable, this can be extended. This is the parity bits. How much parity bits are there? M times T. You understand? If k is increasing, m times T will be what? decreasing. So total number of bits will be fixed. So this is a dynamic system. K can be varied, parity bits can be reduced. If K is length reduced, then M times T will be higher. You understand? It is a dynamic system, and it is also what? A cyclic LBC code. You understand this much? Can we proceed? Yes or no? Yes or no? Yes. Yeah. Next, I am going to define. So is this much clear? So how much redundancy bits? How much redundancy bits? Redundancy means parity bits, extra bits. How much? M times T. N minus K greater than or equal to M times T. And what is T there? Number of errors can be corrected. What is the total block length size? N. That is what? 2 to the power M minus 1. And I have shown an example also. Is it clear? And I told that it is a cyclic LBC code and it is a multiple error correcting code and its properties and the block length. Is it clear? Next we will be dealing with, I will give a quick recap of minimal polynomial over GF2. GF2 to the power M. Okay, can I rub this? So what is, so our ultimate aim is in the BCH is what? To find out which polynomial? The code polynomial. If that is found out, means you can multiply the message bits with this polynomial, you can find out the output, right? So if that is over, all the story is over. You can, from the code polynomial, you can find out the matrix, you can find out the parity check matrix. How to find the parity check matrix from code polynomial? G of x is well known to you. How to find the parity h of x? If it is a cyclic code, x to the power n plus 1 divided by g of x will result in the remainder h of x. Do you remembering this one? Yes or no? So this division will give h of x. Is it clear? This is the property of cyclic LBC. So right now I am going to what topic? Everyone forgot what? Respond. What happened? Is there any problem? Then what happened? Yeah, we are no minimal. Yeah. So I have defined this one. I am giving a quick recap. So if I take GF2 to the power 4, how the elements will looks like? 0, 1, what is alpha? Primitive element. And alpha square, alpha cube, it goes to, total how much elements are there? 16. 2 is already counted. So how much balance? 14. Alpha to the power 14. It is defined over GF2 and listen here. Then alpha is the primitive element, you know, right? Or generator element. And you know that this is extension, right? So I am defining a minimal polynomial. So I told that there is two type of polynomials are there, primitive polynomial and minimal polynomial. Primitive polynomial is like your family name. For GF2 to the power 4, there can be like, what you can say, for entire GF2 to the power 4, it can be represented using what? What minimal polynomial? Primitive polynomial. But minimal polynomial is unique for each element, right? It is one's name. Both everyone's is represented by what? Primitive polynomial. And minimal polynomial is the minimum degree polynomial for the elements to become 0. So for 0, minimal polynomial is what? X. If I substitute here 0, that becomes 0, right? And it is the minimum degree, right? Yes or no? Yeah. and for 1 x plus 1 for alpha. There the problem rise. You don't know how to find, right? For 0 and now you are well known in that, famous in that. For other ones you become how to find. So for that one you should know the n-tuple representation. I have teach you that day I have told you know. So consider a primitive polynomial 1 plus x to the power 4 equal to 0. This is a primitive polynomial over GF. Is it 1 plus x to the power 4? How to check it's a primitive polynomial or not? Substitute alpha. 1 plus alpha to the power 4 equal to 0 or not? Yes. Are you sure? Can we check? 0. It is 0. 1 alpha square alpha to the power 3 cube alpha to the power 4. 1 plus alpha, then is it clear? If you substitute it's okay? Yeah, then it is 0. So like that, so you can make sure and construct what? Primitive. To check whether it's primitive polynomial or GF2, you want to know n-tuple representation, and from n-tuple representation you can substitute and make sure it's 0 or not. So that is about a story about primitive polynomial. But I just concluded we are dealing with what? Minimal polynomial. So to find out minimal polynomial, alpha I told you over GF2, if f of beta is equal to 0, then f of beta to the power square also will be 0. This can be f of beta square equal to 0. This we have proved, right? For GF3, GF2. So similarly, all the conjugates will be what? 0. So to find out alpha, first the root of the minimal polynomial is what? Alpha. Then what? Alpha square alpha to the power 4. That is what? Alpha plus, or you just write alpha to the power 4. Then alpha power 8. Then alpha to the power, that is what? So that's a repetition, right, of these roots. So over GF to the power 2 to the power 4, right? Only 4 roots. So we can stop with the 4. So that polynomial we are having 4 roots. Using factor theorem, how we can write the polynomial? So m1 of x, m1 means alpha to the power 1, will be what? Or phi 1 of x. Don't be confused with message bits. So phi 1 of x is what? X plus alpha into x plus alpha square into alpha to the power 4 into x plus. You can reduce either this way, or the next method is what? Next method is what? The things, okay, that you also know how. X to the power 4 plus a0 x to the power a3 x to the power 3 plus a2 x to the power 2 plus a1 x to the power 1 plus a0. This you consider it as phi 1 of x. Then substitute for alpha and find out all. You put it as all to alpha to the power 4. You substitute and you will get how much equations? 3 unknowns, 3 equations by separating alpha to the power 3, alpha to the power 2, alpha to the power 1, alpha to the power 0. You can separate and find out these coefficients, right? So hope you know, I have taught you this earlier also. So I am just concluding the minimal polynomial for GF2 to the power 4. The minimal polynomial of 0 is what? X, and 1 or alpha to the power 15 is what? X plus 1, and for alpha square alpha to the power 4 alpha to the power 6 8 alpha to the power, that's it. It is what? X power 4 plus 1. And for alpha to the power 3, alpha to the power 6, alpha to the power 9, alpha to the power 12, it is x x cube plus x plus 1. For alpha to the power 5, alpha to the power 10, it is x square plus x plus 1. Then for alpha, is it changed? It is alpha x plus 1. Then alpha to the power 7, alpha to the power 14, alpha to the power 13, alpha to the power 11. It is what? X cube plus x plus 1. Right? Is it clear? Yes or no? If any doubt is there, you check. Okay. So if you know this earlier, it's easy to proceed. Otherwise, your time will be going. Okay. So hope you practice with this one. Okay. So this you remember. This is very much required in the BCH code. Then we will be finding out. Next aim is what? To find out. What is our aim? Chord polynomial. So for chord polynomial. One more thing is there. For BCH, I told that it is defined over 2 to the g of 2 to the power 2 to the power m. M should be greater than or equal to 3. Why that so? Just think. Why m should be greater than or equal to 3? Just think. If m is less than 3, which means 2, how much are there? 0 or 1. Is there extension is possible? Is there minimal polynomial? That is just binary, right? We are dealing with the multiple correcting codes and things, so it should be defined over extension. So for extension defining, how much elements should be there? Minimum 3. So it is defined over m greater than or equal to 3. And for chord polynomial, if t is given as 3-bit correcting code. Listen here everyone. If 3-bit correcting code, g of x is defined as LCM of phi 1 of x, phi 2 of x goes up to phi of 2 to the power say, x. Is it clear? Just dividing. Why that so? Proof is not required. Its chord polynomial is LCM of, everyone listen here, LCM of, what is phi 1 of x? Minimal polynomial of alpha to the power 1. What is phi 2 of x? Alpha square. Up to how much we should go? If t is equal to 3. T is equal to 3. 6. So, in this case, g of x equal to LCM of, tell me, respond. Phi 2 of x, phi 3 of x, phi 4 of x, phi 5 of x, phi 6 of x. Just look there. This is what? This one, right? This polynomial, right? Everyone listen here. This polynomial, right? For alpha square and alpha, the same polynomial. LCM of 2 and 2 is what? 2. So if both are same means 1 we can cut short, right? So for 3 and 6 also same, right? So we can cut short what? 6 and alpha 2 and 4. So we can cut short. Is balance everything independent? Having different LCM, say everything different polynomial, right? So can we just multiply that? Yeah. So what is phi 1 of x? 4 plus x cube plus 1 multiplied by phi 3 of x to the power 4 plus x to the power 3 plus x to the square 1 plus 1 into x plus 1 into actually its square is also there. For all powers are there. Square x plus 1, then next phi 5 of x. X square plus x1 of x. Why? Any doubt is there? Is it easy? Just what is the check whether what is how much t is there. That much will be take. Okay. Then we will check alternative terms. We will take only the odd ones. Then just multiply. We will get g of x. That's it. It is defined over which? 2 to the power 4. So what is n here? block length 15, and what is n minus k? 4 into 3. So what is k? Less than or equal to 3. Its representation is 15 comma 15 n comma k, 15 comma 3. So what is the polynomial here? You multiply this one, that will be the chord polynomial, and if you get the chord polynomial using cyclic LBC, you can generate the generator matrix. You can do the row operations, whatever the things you want, you can decode. Okay, if you are having message bits 1, 0, 1, how this chord polynomial, message polynomial will looks like 1 plus x square. To get output, you multiply g of x with the m of x, you will getting y of x, that is the output of this one. Is it clear? Is it clear? So only 0 and 1s in BCH. The next code is what code? RS code, Reed-Solomon code, but it is non-binary BCH. Same BCH, but it is not binary. So it is not meant for what? 0 and 1, it is meant for extensions. Okay. Is it clear, everyone? There we required primitive polynomial. Right. We will be discussing the problems, don't worry. So you understand why, how to find the chord polynomial. That's the main thing you should get from here. So the BCH is defined for m. What is the condition? M greater than or equal to 3. You understand why the concept? What is the... Okay. Everyone respond in the class, okay? Otherwise, no more use of sitting here. Okay. Please respond. Your response is much required in the class. That's the support for a teacher. Okay. So, the minimal polynomial and the generation of chord polynomial of BCH is completed right now. So we wind up BCH. Now the next code is RS code or Reed-Solomon code. That is what? Non-binary BCH, and it is defined over GFQ or GF2 to the power m, and the condition, we know that for every Galois field there exists a what element? Non-zero primitive element. We have shown the proof, right? So there whatever the GF2, GF4 is possible. Is GF4 possible? That's possible. The straight GF4 is possible. Extension you leave. GF4 is possible or not? Why that so? Prime cannot be possible. So the extension is okay. You can't write GF straightly GF4. That can be the other meaning. So GF2 to the power 2 is okay. GF4 is not okay. GF4 is represented by how much? 0, 1, 2, 3. That is not a Galois field. Okay. We can't define it as a finite field because its characteristic will goes away from the theorem and contradicts. So only for what is the? For prime numbers. So here also block length will be q minus 1. And which means 2 to the power m minus 1, and redundancy bit is there is a difference 2 times t, not m times t, that is 2 times t, and d minimum is what? That is same for all the codes. It should be greater than or equal to 2t plus 1. Is it clear? And instead of m times t, here it is 2 times t, that's the difference. Is that okay? So GF 16 2 to the power 4, what is n? 15, what is t? So if it t is 3 error correcting codes, what is n? What is k? 2 into 3, so what is k? What is k? What is k? 9. Less than or equal to 9. You can see that in the earlier case, n is equal to 15, k was 3. So what is the rate? 3 divided by 15. Here you can see the rate is increased, which means out of n bits we are getting more number of useful bits. So it is a high efficiency coding. That is a very high efficient coding because the rate is high. So it can be applied for DVD, you know, right? CD. How the CD is working, we are writing the data into the registers inside the CD. So this can be used there. Practical applications can be used what? RS code, and there is new codes are called turbo codes, and high parity LBC is there. That's a current trend now. So this is also a good coding concept, RS code. You know why it's that's so? The rate is K by N, that's rate is high now compared to BCH code. Pretty clear from here. So here also we can show the block length. So N is fixed and K, this is, here also K is what? Variable, because it should be less than or equal to 9. So what are the things? If this is reduced, parity bit is increased. If this is increased, parity bit is reduced. Same concept, nothing is there. Instead of m times t, 2 times t. And here the g of x is nothing but x plus alpha. What is alpha? Primitive element of a Galois field into, it will goes up to x plus alpha to the power 2t. Here no reduction is there, LCM nothing is there, just you multiply. So you, if g of 2 to the power 4, so what is the, how much is there? Up to, if 3-bit correcting code means alpha, so if g of 2 to the power 4, n is what? 15, and if t is equal to 3, so what is g of x? It is x plus alpha square, you can go to x plus alpha to the power 6, and over, this is alpha, right? You know the n-tuple representation, and you can reduce, right? If higher degree is coming, and alpha to the power 15 is what? 1. So alpha to the power 12, everything can be decoded from where? N-tuple representation, and you can reduce this to a polynomial, right? Yes or no? So if message which is given, how multiplying we can get the output, right? What is the use of this RS code? It's a high efficiency code, because of why? The rate is high. K by N is high compared to BCH code. So we completed both codings. So if g of x is given, you know, you should know how to convert into matrix. This is a cyclic BCH. First you fill with the first row of A. If g of x is 1 plus x cube, what is polynomial? 1, 0, 0, 1. So first you fill with 1, 0, 0, 1. How much? For getting n size, fill it with the zeros. First you put 0, then you 1, 0, 0, 1, 0, 0. You have defined this or no? For a cyclic LBC, here also it is cyclic LBC itself. Both are cyclic LBC. So you know how to convert into parity. This is what? Generator matrix. You know how to convert into parity check matrix. How to generate h of x? Dividing it with the h of n, x of n plus 1 divided by g of x. You can find out what? You can find out h of x. Similar concept for parity check matrix. Can we deal with the problems now? Can we deal with the problems? Why everyone is sleepy? What happened? Is everyone sleepy? Are you thrilled to practice the problems? No response? Yes. So we will be dealing with the problems of 2. So I won't solve. We can separate this one. So this is A part and this is B part. Let me check who is good at coding theory, because I have covered everything from the scratch. We can check. Depending upon that, price will be there. Okay. So this is A part and this is B part. Let me check who is genius. Not genius, who is hard worker. Nothing much genius is there, only 0 and 1. So a 5th standard student would be able to decode this all the things. Nothing much for a 3rd year engineering student or SEM 6 student in NIT Calicut. So yeah, the first one show that the code 000 1100 and 0011 1111 is a linear code, only a linear code, nothing much. Then find out the minimum distance, minimum Hamming distance. Oh, that you are famous. Minimum Hamming distance, I know. I am very much pretty famous in that, because find out alternative minimum Hamming distance, take out the minimum. Oh, I know. It's clear. What is a linear code? So that concept is missing, right? It's very easy. Check. Can you check whether it is a vector space? How? Check whether it is closed or not. That's the same concept for linear code. In linear block code, not linear code. So check whether it is closed or not. If you add this one is there. If you add this one, that is there. If you add this with this one, that is there. Everything is closed, right? So it is closed under what? Under addition. It is closed under scalar multiplication. Did A dot B is equal to 0 for A is equal to 0 and A is equal to 1? Check whether 1 dot this 0 vector, which means 1 into 1, all bits we will be multiplying with what? 1. That result in what? 0 0. It is there, right? So did this satisfy the scalar multiplication? It is closed under scalar multiplication. This one also, right? This one. So it follows. Did everyone get? Yeah, very good. Next, consider the generator matrix. Yeah, consider the generator matrix or GF2. Okay. So 1 0 0 0 1 0 0 0 1 1 0 0 1 1 1. So how much represent this as represent? What is the representation of this one? How much rows and how much columns? 3 rows and 5 columns. So its representation 5, 3 or n, k. Then your question is generate all the code words using this matrix. What is the input combinations or input vector space? 3 is the, so 3 times. So how much possibilities are there? How much combination to the power 3? That is 8 combinations are there. You can multiply. These are identity matrix, right? So the first bit will be dropped here, second bit will be dropped here, third bit will be dropped here. Depending upon this one, you can generate all the code words, right? Yes or no? So be able to do that. Can I move ahead? The second question is find the parity check matrix. Is that okay? So how what is parity check matrix? P transpose I. What is P here? This one, right? So you can do that, right? So this one you extend with the I or the ulta thing. P transpose I. Is it okay now? Construct a standard array for this code. Standard array decoding. How it's doing? How much, let me ask you, how much combinations are there in the input side? 8 combinations are there. How much total code words in the output? 32. Am it's are correct? 8. So 32 words in a bucket. We want to group into now. We want to group into 8 buckets. So 8 is divided. So how much in each bucket? 4. So you write each the leader Then you introduce how much maximum error it can be corrected? D minimum minus what? What is D minimum here? Eh? What is D minimum? Having distance. You find out D minimum. Okay, suppose it be 3. So it is 3 minus 1, 2. Maximum 2 errors can be introduced. So you start with the single bit error. You continue, and how much you can generate? You can generate a table, standard array table of how much groups? 8 groups, and each group is having one leader. Is it okay now? If something is coming through air, then you will be mapping to each group and selecting the leader. Is it okay? At 32 possibilities the output. Among 8 only correct. So you will be picking out. Is that okay now? So the next one is, what is the minimum distance of the code? You can find out, right? You generate all the code words, find out the minimum handling distance. How much errors can be dictated? D minimum minus 1. Can be corrected? So what is the probability of undictated errors? Can be corrected? What is the probability of undictated codes? How much it can dictate? How much total is there? You divide. Is that okay now? Is it everyone okay? How much n? How much is the total n? How much it can be dictated? Undictated codes. Total how much bits are there? You find out how much it can dictate. How much it can't dictate. Total bits, output bits are n, right? So how much you subtract undictated divided by total. That is what undictated probability. You can find out, right? Is that much difficult? No. What is the, based on the standard array, find the probability of decoder error. How to find out that? In each group, how much total is there? 4. One is correct, right? So what is the probability? 1 by 4. It is extended to 8 groups. So the total error 1 by 4 into each group is having an error of what? 1 by 4. So for first group 1 by 4 error, next group is also having what? So if the message bit is coming, first we should group into a group. First 8 groups are there now. The first message which is coming through air. So how much possibilities? 1 by 8. Inside that 1 by 8, how much error is there? 1 by 4. Not 1 by 4 into 8. It's a 1 for 8. You think when a message bit is coming, so how much first probability is there? 1 by, among 8 groups we should select 1, right? So among 1 group it's how much errors can be there? 1 by 4. So total error is how much? Is it clear? Yes. Is there any objection is there? 1 by 4 into 1 by 8. So write down the Coset leader for this code. What is the leader of the standard array? You know, right? Just pick it out. If the received vector is 11010, what is the code word mapped to? Just to pick out the code. That's it. Next, the third question. The parity check matrix for a code word given as 10101101. It is P transpose I. By parity check matrix can be converted reverse back into generated matrix. Is that much a big thing? Yeah, we are big students now. So P transpose I, you can take out P transpose P, and how we can write either at the start or the end, that you can choose. Can you list out all the code words? Very easy now. You check on how much rows are there, that much input messages will be there. Here how much rows will be there? I evaluated, because you will be shaking your head at the time of exam, you know nothing. So I will be doing now itself for my safety. So H is equal to, yeah, 1 0 1 0 1 1 0 1. So this is I and this is what? P transpose. Then what is P? 1 0 1 1. So for generator matrix now either I at the start or I at the beginning. So 1 0 0 1 1 1 0 1. This is the generator matrix. How much rows? 2 rows. How much columns? 4. So it is a 4 comma 3 4 comma 2 code. How much possibilities at the input? How much code words? 4. That's it. So can you list out all the code words? Easy now. Nothing is there. Find out the corresponding generator matrix. Can be converted? Oh. Find out the minimum distance, error correction probability, capability. How much maximum error it can be detected? D minimum minus 1. How much it can be corrected? D minimum minus 1 by 2. So you know. Next question. Is there any problem? Question number 4. No. That's correct. If generator matrix is given below, give another generator matrix for the same code. Row operations. Make here you can see that generator matrix is part. Just tell me fast. Generator matrix is G is equal to 1 1 0 0 0 0. Okay. Then next one 0 0 1 1 0 0. Next one 0 0 0 0 1 1. So is this will generate systematic codes or not systematic codes? Not systematic codes. So how to make it systematic codes? Row operations. Where to make the row operations? Most easiest part is where to make the row operations. Where? You can add these two. Right? So it will be what? 1 1 0. Similarly, you can add this one also. First row and second row. Then you add to the first row all the rows. Is it clear? I will do that. First, you to the row 1, you add R2 plus R3. So it will be how much? 1 1 0 1 1 1. R2 plus R3. So 0 0 1 1 0 0. The last row will be what? 0 0 0 0 1 1. Now to make it only 1, what we should I do? And our aim is what? 1 0 0 0 1 0 0 0 1. So to make this 2 0, what should I do? R1 plus R3. So what is that? 1 1. Tell me. 1 1 0 1. Here also last. Okay. 1 1. Now it's 1 1. 1 0 0. Is that okay? The next row is what? 0 0 1 1 0 0. The next row is what? 0 0 0 0 1 1. So target from the second row. Add these two. This two is what? 1 1 1. Is that possible? Not possible. Then from where we should start? No, they have asked given another generator matrix, so you know. I don't think so. We got to proceed with the systematic codes. Do either one of the row operation generate that, give that, because one row operation is enough for doing that. Sometimes you may not be able to find out the systematic codes for this code by doing the row operations. That's not our problem. That's the generator matrix problem.
They only ask what? To give another generated matrix. You can do either one of the operations, conclude. That's it. The next thing. The next question, read out. A binary cyclic code of length 15 has a generated polynomial g of x given as so and so. Give a generator matrix and a parity check matrix for the code. Also find out the parameters n, k, d minimum of the code. So is code polynomial given to you? Yes or no? You can find out all the message bits, right? And this given, n is given. n is given and is clearly stated that g of x is equal to x to the power 4 plus x to the power x plus 1. So x power 4 plus x power plus 1. So what is the code polynomial? Multiplied by x to the power 3 plus x to the power 3, 2 plus 1, right? X plus 1. This is what? The generator polynomial. You can find out by multiplying what? The mod polynomial. You can find out the generator matrix. If you want, you can find out. You was given, n is given. From there you can conclude what? Writing the matrix. Multiply. Yeah. A generator polynomial is given now. So you can multiply and you can find out what? The very lengthy one. That you can what to conclude how we can write? To generator matrix append zeros. Then how much rows is there? You can check how much rows is there. N, k. From there you can list out the code words. From there, yeah. Yeah, what's the wait. A binary cyclic code of length 50 as a generator polynomial g of x is given as x power 4 plus x power plus 1. Highest power of g of x is what? N minus k. Right? N minus k is what? We don't know. So n is what? 15 minus k is what? G of x should have the power of n minus k. Right, the maximum power of n minus k, g of x, I have proved that you remember n minus k. Then it should be, n is what? N is what? 15 minus k is the highest power. So the highest power, I mean, this one is what? 8. So what is k? 7. So how much passage combination? 2 to the power 7. So that much combinations will be there. And to find out d minimum, is there any other shortcut? For a cyclic code, you have concluded that day one thing. Just you remember. For k is equal to how much message bits, hopefully that will be how much. If k is equal to 3, that much d minimum. You check, okay. For that, there is a thing that I told you. For cyclic codes, d minimum can be, we have concluded 2 or 3 cases, and we have like last we concluded d minimum is equal to this much for whatever the case. You can check your notes. D minimum actually you have to find out the code words, then find out all the possibilities, get the minimum of this code. Okay. Here you know n and you know k. Then to find out d minimum, so 15,7. The d minimum will be what? Either you can find out all the possibilities, check that one, or the property of cyclic cyclic codes, block codes, there is a property that it divides with the D minimum. That is notes is there now. D minimum. I have concluded both. Some cases I have wrote, and for whatever the case, we have concluded D minimum that day. We check there. Okay, I just forgot. I remember which I'll continue. Okay, alright, in the next class. For next question, n comma k you know, right? D minimum I have taught you that day. It's there in your note. Just forgot now. Okay, so the next question, sixth question. We are running out of time. G of x is equal to 1 plus x square plus x to the power 4 plus x to the power 6 plus x to the power 7 plus x to the power 10 is the odd polynomial for 21, 11. Give a generator and pattern check matrix. Is that okay? You can do. Next question. Determine the dimension and generator polynomial of all primitive binary BCH of length 31. So n is what there? 31. It is what? 2 to the power? For BCH? 2 to the power? M is what? 5. And its representation is what? N minus k. It should be greater than or equal to mt. So what is here? M. 5. And what is t is there? So t is not given. Binary BCH. For all the primitive binary BCH, actually it should be given. The errors also should be given, because BCH is defined for this much error, for this much error. Or if it's not given, assume t is equal to 3, then you can proceed. You can find out the dimensions. If t is equal to 3, then how much k? 15 minus, or you take out less, 2, 10. So k should be greater than, less than or equal to 5, and code is 31, comma 5. So what is the range of that code? 5 by 31. That's it. Next question. Find the generated polynomial of the length. Length is 1, 0, 2, 3. So m is what? 10. And they have asked that decide with the distance d is equal to 3, d is equal to 5, d is equal to 7, d is equal to 9. So hopefully d is what? T. So you can n comma k representation you can find out right very easily. Same question. 9th one. Suppose that double error correcting. This should be like the form. Double error correcting. So d is equal to t is equal to 2. Then like this what? M is you what happened? Next you focus on question number 9. 9. So what is double error correcting code? N minus k should be greater than or equal to m times t. T is what? I assume that as 2. So k should be less than or equal to 15 minus 10. M is what there? 5. Oh, sorry. It should be 31. Sorry. 31 minus 10, that is 21. So it is 31, 21. Sorry. I have made a mistake there. So question number 9 you choose. Yeah, what is n there? Day. What is n? What is n there? What is m there? What is t there? 2. Then you can find out the representation. What is the representation? M 31 comma. Hey. At least you respond. Then you know this one we are doing so at least you do the problem. N is equal to 31. This part this calculation. What is there? Actually n is 31. M is what? Are you kidding? N is 31. Just be okay. Don't be childish in the class. N is equal to 31. M is equal to 5. Just be a calculation. T is equal to 2, and what is k? 21. So its representation 21. Okay. Decode the received polynomials. How to decode? So you know how to find out g of x for t is equal to, that is phi 1 of x. And what you are looking? It's not story, you learned everything, then just tell me. LCM of phi 1 of x, phi 2 is not there, phi 3 of x, how much? 2t minus 1. So 2 into 2 minus 1. So up to how much is there? Phi 1 of x and phi 3 of x. You can find a g of x, right? So m of x into g of x gives what? Phi of x. So from there you can find out m of x. Just divide whatever given with g of x. Nothing much common is there. We have it. N is given to the power m minus 1. N is given 31 plus 1. What is m? Galois field extension 2 to the power 5. We haven't mentioned 4 or 3 there. It is given from the problem. Okay, next question number 10. Can you do the question number 10? With that we will wind up. Just pick quick. This is the question from what? And at least you respond. Don't be like puppet here. I don't want any student like to be a puppet here. Because you know all the concept from the scratch. I have told you, I have told you, then what is there more? Just read the question. So, convolutional decoder and encoder is given, the circuit is given to you. How much outputs are there, how much inputs are there? But at least respond. How much inputs are there? 1. How much shift registers are there? 3. How much outputs are there? 2. So its representation 2, 1, 3. So how much input combinations are there? 1, 0. So how much states are there for this one? How much states? 8 states. So how much draw the diagram? First you consider the state table. State table, how much rows are there? 8 into 2. 16 are there. So you can concentrate state diagram, state table. And what happened? If you know, yes. If you don't know, no. Just stand with it, yes or no. Don't be. I can understand. I can't understand whether you catch the idea or not. If you don't understand, just raise your hand and tell. I don't understand. I am ready to explain. But if you stand like this, means I'll assume that you understand. I will go ahead. Don't be like that. Okay. If you know means I know the answer. Tell genuinely to doctor, advocate, and teacher. You shouldn't hide any lies because that will affect your future. If you hide now something, the next exam day you will cry or you will be. But oh, if I tell that day, he may explain more. I may get the idea. So don't get that regret now. If you have any problem, just raise your hand now. Tell genuinely. Don't look at your friends. It's up to you. If you know, you only getting the benefit out of it. So you know the state diagram, right? State table. So you know how to construct. I have told it. You know, right? We have practiced many examples also. So trellis diagram. For 16 is you leave. That you leave. Just you consider the trellis diagram for 8 stages. That's the mistake. Okay. Encode the infinite message given. How to encode? Using polynomials. How to encode? I have told you how to construct the output. How much outputs are there? 2 outputs. So let it be y0 and y1. We can convert all this diagram into what? Into impulse response. You can find out the impulse response, right? So you can find out the G0 of x and G1 of x, right? You can multiply and you can find out the what is the total output y of x. Y of x equal to, in terms of y0 of x and y1 of x, how much elements are there, how much output? 2 output. So y0 x square plus x times x square. If you know this 2 output by impulse response, if message bit y0 of x is what? M of x into g0 of x. You can find it very easily g0 of x. If you know the state table, you can find the impulse response. You know, right? We have practiced the similar problems. Hope you know. It's lengthy, I know. I accept that. I appreciate you for doing that. But you should do that. Next question is decoding. Infinite message sequence. If 3 outputs are there, y0 of x square plus x into y1 of x square plus x square into y of x square. This depends upon x to the power n, how much outputs are there. We will be shifting each one. So x output is 2. Then how much of y0, y1 and y2 will be there? So y0 of x square, x times y1 of x square. No, this is just x. X into y1 of x square plus x square into y2 of x square. This is 1. X to the power 0, x to the power 1, x to the power 0. This we are shifting 1 units. Okay, that's it. This is what I have told that day itself. And this is x to the power 2. That is depends upon n. This just don't depend upon anything. How much output are there? We will be powering more with the x. That's it. No much comedy is there. Do next question. Infinite. Infinite you can multiply with the, if g of x is given. If you know the impulse response of these two, if suppose it is given 1 0 1 1 1 1 1 1. If suppose, what is our message bit? U of n, you can take out the convolution of u of n with the g0 of n, but it is infinite messages, right? So how to find, if you know how to find the response to what? Impulse response. Similarly, you have to find what? To 1 1, then you will reach the which state? Freezing state, you stop there. Okay. Then you pump 1, no more use is there. So if the message is infinity, you can't do with this one. You should go with the manual thing. You can work out. Okay. So next question is what? Decoding. So mainly in convolution block codes, how we are decoding? Using what diagram? Trellis. So the given is, it is given through air. This is coming. So we will be grouping into what? How much bits at a same time? How much output is there? 2. Total how much outputs are there? 2, right? y0 and y1. So we'll be grouping into 2. From trellis, you start with the which stage? 0 0. You draw the trellis and you find out the each stage you calculate the d minimum. At the end you find out the minimum d minimum, trace back. Then how many survivor path would exist after each stage? Which means, right, at a first stage how much paths are there? 2 paths. Next stage how much paths are there? 4 paths. That they are asking. You understand? Given the constraint length of the code. So each stage you have to count out. No. This first stage, this much, second stage, this much, fourth stage. Just how many surveyor path would exist for each stage? Don't add nothing. For each stage, how much is there? How much stage is there? You can find out the sequence, how much you group into 2. So that much stage will be there in the trellis. For the first stage, this much path. Next stage, this much path. They don't ask to add or something, anything. They ask to find out for each stage. That's right. Yeah. least one, for the least d minimum. Okay. And for each distance, for each thing, we'll get 3, 2, 2, 1. So you take this as the least one. Okay. Then give the constraint length of the code. Give the constraint length of the code. How to do that? Have we studied that? That I will tell later. Okay. I will discuss. If anyone is having problem sheet number 1, just share now to me. Problem sheet 1. We'll be quick review of that one. We'll do. Problem sheet 1, just you share the points. And these students again, and if you know something, speak out. I am just a friend, right? Not a teacher, nothing is there. You speak out. You understand these things or not? Okay. I am asking myself and answering. You get your points. And if out of 15, 1 or 2 you don't understand, means don't speak out. That's not a good thing. Because the teacher is expecting whether you understand our things. 1 or 2 you may be not understanding. I also may be not understand the whole thing. But you got something out of this one. I whatever told you won't answer this one. This is from the starting to this end of the class. Tell whatever. Do whatever you want. And don't be like that. Be supportive in the class. It's your responsibility. If you need more from me, you should be responsive in the class. Did you get something out of it? Yes. Now response is there. After next time I ask, actually from where this character you wrote? From where the character is picked out? And let's share. Yeah, I got it. And the first question, consider the group under modulus 6 addition. I have told you 0 to 5. Next question, consider the prime field G of 11 with the modulus 11 addition. Find all the primitive elements, determine the order of other elements. You know, right? Next question, prove that every field has a primitive element. You know, right? I have told you in the class, just look the notes. Next question. Show that x to the power 5 plus x to the power 3 plus x plus 1 is irreducible over g of 2. So start with the x plus 1 combinations up to what? X to the power 4. Next, construct a table for g of 2 to the power 3 based on the primitive polynomial. What table we want to get from there? N-double representation. So power and everything you can find out from there. So next question, construct a set of n integers. What is that? Z is equal to 0 to n minus 1 and represent modulus n addition and multiplication. What is that? A group over 2 operator. Field. They are asked whether check whether it is field or not. Choose for n some value, check whether it is field or not. Okay, check whether Zn plus is a group. And Z dot, which means dot is means non-zero. So non-zero is a group, and whether check is abelian group or not. Thus, this both forms a field. Is that clear for you? And just take any small example and do that. Just next case is that B be a vector space over GF. Prove that minus E dot B is equal to 0 minus V is equal to minus E dot B. How that do is that C is a field element. Listen here. C is a field element. So suppose GF. So how we can represent a vector? Everyone. V equal to V0, V1, V2, V3 up to Vn minus 1. So if you multiply constant, how it will be represented? CV0, C1, CV3, CVn. You understand this much? Then you multiply minus C times Vn. Just do the ulta things and everything prove. Everything will result in the same thing. You understand? Either you can prove like this, or if you want V dot 0 equal to 0, or V dot C minus C is equal to 0, V dot C minus C dot V is equal to 0. So V dot C, reverse case, C dot V will be equal to, you can prove like this. What are the things you can do? Next question. Let A B be a vector space over 2 by 3 matrix or G of Q addition multiplication. Write a set of basis vector for V. So it is V is a matrix. So how much rows and how much columns? Yeah? Hey, what happened? How much row? I don't know. Dinesh, now it will be like this. What is the difference? Now we are like that. And if you know how much rows and how much columns? 2 rows, 5 columns, 3 columns. Then you think about 2 rows are there, 3 columns are there. This is one matrix. So A, B, C, D, E, F are the common things. So what is the basis vector? So for creating individual A, we have to multiply 1, 0, 0, 0, 0, 0 for controlling the element A. So for controlling B, so how much basis vectors are there? That's it. Then you can write out the dimension for the space. Write a basis vector K minus 1. Basis vector is what? So how much are there? 6. You remove 2. If I am removing this one and the second one, first in 2 terms will be what? 0. So this 4 basis vector. This one is how much basis vector? 4. That's it. Next question. Construct a vector space of 3 tuples over F3. So 3 tuples over F3. But elements what is what? 0, 1, 2. How much bits are there? So how much possibilities? 27. Find 4 by 2 dimensional subspace and the dual space. This problem we have practiced, right? This is the same we have given in the midterm. So which of the following is not a Hamming code? Not a valid Hamming code. How to find out that one? N comma K representation is given. From there, N greater than or equal to N greater than or equal to K, and Hamming code is not valid. How to check that one? And that portion is lacking from ours. That will update later. So the next code word is given now. Same question we have practiced. And I consider the following GF generated matrix. Generate all the possibility code words. Find the parity check matrix. What is the minimum code word? If the received code word is, which code word is mapped to? That is the decoding part of what NPC. How it's doing so? Decoding part 2 method are there. Error syndrome and standard error decoding. Here we will be using what syndrome? Error syndrome. Check code. C dot H transpose is equal to 0. If it's 0, no error. If something is there, check what is inside the H transpose. That position we will be having error. So the output will be what? Put the ulta at that position. So the next matrix. A generated matrix is given. Give another matrix for the code. Draw operations. Done now. So some questions I haven't discussed. I will be giving the solutions in the group. So this was the last class of NITC. So thank you everyone for sacrificing me for this much time. I know that I was angry many times because You guys made me that. Okay, so hopefully this was my 13 hours of ITC coding part. So I took 13 hours. Is there any use for 13 hours? What are we learned from the very starting? Eh? Let me tell, can anyone tell from where I start?
Set.
No. Factor theorem. So are you set? Yeah. Then group properties, field properties, finite field. That is called what? Galois field. It can be prime. There exists a character. There is a primitive element for every finite fields. Then primitive polynomial, minimal polynomial. After LBC, extensions is there. LBC is vector representation, generator matrix, generation, coding, encoding, then decoding. Two methods: error syndrome and standard array decoding. Then what happened? Then two concepts are missing. Can be dictated, can be corrected. Then cyclic LBC. There I have showed you how to find the shifted one. You multiply x, how much shift is there, multiplied with v of x divided by x to the power n plus 1. Then the generation of systematic codes using non-systematic code polynomial. How is that so x to the power n minus k into m of x divided by g of x, whatever given, plus nuls. What is nuls? X to the power n minus k into m of x. Next, CBC diagram, state table. What is state? Right now, what is my state? Happy. Okay. So how many states are there? 2 to the power m. So that much states are there. State table, state diagram, trellis, decoding part using trellis. Then next, BCH. What is BCH? As something leave. It is cyclic LBC. And how much redundancy in the BCH? M takes T. And what is M block length? 2 to the power m minus 1. So it is dynamic system. And we have studied the g of x also using part polynomial, minimal polynomial. Then what is RS code? There m times T is 2 times T. You can find out T and you can find out the g of x. It is likely CBC. So you can find out the generator matrix, parity check matrix, everything you can find out. So finally I concluded with the problem sheet 2 and problem sheet 1. That's it. Is it okay now? Happy everyone? Yes. So thank you everyone. It was very nice for section. I know I am stressed like so much. I made angry with you all. But if I handle this section very strict, then only you will be listening in the class. Otherwise, you will be feeling sleepy. That's why I am asking you respond in the class. Because this response make you know up to till something is you done. So thank you SDC for allowing me to conduct this class. So signing off from NIT CALICUT. Bye.